All right, so all of this stuff on this page is kind of stuff we just figured out on our own, but try to remember that the secant is the reciprocal of the cosine, and the cosecant is the reciprocal of the sine. And anywhere where the sine is 0, the cosecant is going to be undefined. And anywhere where the cosine is 0, the secant is going to be undefined. And people have a hard time remembering that. So remembering that secant and cosine go together and cosine and sine go together. So just try to remember that S is going to go with C. And then hopefully you'll get that. And then the tangent and cotangent are reciprocals of each other. It's easier to remember those because they sound so similar. But the cotangent is the reciprocal of the tangent, and anywhere that tangent is 0, the cotangent is going to be undefined. Another way we can write cotangent is the cosine of x over the sine of x. It's just another option for you. All right, and then all of the reciprocal functions have vertical asymptotes. And the distance between those vertical asymptotes is going to be pi on all of them, actually, unless there's some kind of dilation. And then the ranges of secant and cosecant are what we wrote on the other paper. Right. And then there's cotangent. The distance between the vertical asymptotes is also pi. Right. Cotangent is going to be a sad graph. It's falling always. But a negative cotangent does end up being happy. So. Okay, so let's answer some questions about vertical asymptotes and the range of transformed graphs. All right, so for number 1, we have f of x is 3 secant of 2x. Which of the following is a vertical asymptote of the graph of f? And so this one has 2 transformations. It has a vertical dilation and it has a horizontal dilation. Which one is going to affect the vertical asymptote? How it changes vertically or how it changes horizontally? Horizontally. So only the part inside the parentheses is going to have an effect on the vertical asymptote. And so you, like right now, if you wanted to pull out your graph that we did a second ago, you can see where vertical asymptotes are of secant if you're on the cosine side. Or you're not always going to have that, but hopefully when you take the AP test, you're going to draw out a unit circle, and then you'll know whenever on the unit circle that the cosine is 0, then the secant is going to be undefined and have a vertical asymptote. So if you're looking at a unit circle, Kaylee has a unit circle, what is the first angle as you're going around when the cosine is 0 or the x coordinate is 0? Pi over 2. All right. So we're going to take that 2x and we're going to set it equal to pi over 2. Set it equal to where the parent function has a vertical asymptote. And then we're just going to solve that for x. We've done this with different things. This is the first time I think we've maybe done it with vertical asymptotes. But what would you do to solve that for x? Thank you. I'm going to divide by 2. So what is pi over 2 divided by 2? Pi over 4, which is choice C. Now, if for some reason that doesn't give you one of the answer choices, there are other vertical asymptotes we could try. So you could take 3 pi over 2 and set 2x equal to it and solve it that way, but it shouldn't take too many times. Or you could just add, let's just do it that way. Okay, so for example 2, we have a lot of transformations. We have a vertical translation. We have a reflection across the x-axis. We have a vertical dilation, and we have a horizontal dilation. But this one is still asking you for a vertical asymptote. So still, what's inside the parentheses is the only thing that has an effect on that vertical asymptote location. So we'll take pi over x. And this time we are not going to set it equal to pi over 2 because this one is cosecant. And so we want to know where the cosecant has a vertical asymptote. And so the cosecant has a vertical asymptote anytime sine is 0, which is 0, pi, 2 pi. I need multiple of pi. I probably wouldn't do 0 here because I know if I set this equal to 0, I'm going to always get 0 unless there's some kind of addition or subtraction in the parentheses, and there's not. So if it was me, I would set it equal to pi. What happens when you solve this for x? You go 1, which is the answer choice. All right, and then example 3, totally different question, is asking us about the range. So we have h of theta is 3 cosecant of theta over 2, and we want to find the range. So what we're going to do is take the original range of cosecant, it's going to be negative infinity to negative 1, 1 to infinity. That is an answer choice. It is not the answer, though, because this one is transformed. So anytime there is some kind of vertical dilation or translation, it is going to change the range. It's either going to stretch or it's going to shift the range around, sometimes both. This one stretches it. So which answer choice do you think is going to be it? 3. Multiply by 3. So what you're going to do is just multiply your range by 3. Now be careful, because sometimes you have to multiply and you have to shift. And so it changes it a little bit. All right, and then number 4. We have k, which is negative 5 cotangent of 2 pi x. And we want, this one's asking about vertical asymptote again. Vertical asymptote, we care about horizontal changes, which is inside the parentheses. All right, for cotangent. Cotangent is going to have a vertical asymptote anytime tangent is 0, which is at 0, and at pi, and at 2 pi. And again, unless you have an answer that is 0 or there's addition or subtraction inside, I wouldn't use 0. I'd go ahead and use pi. Sorry, I don't even know what I'm doing. There we go. And then solve it for x by dividing by 2 pi. And so that's going to be b. Now, I know we have learned so much about all the trig function graphs and where they have maximum and where they have a minimum, and it's a lot to remember. Your unit circle, when you're trying to remember all these things on the AP test, is probably going to help you because you can get an idea of what's going on with the graph, I think. All right, and then the last page, we're going to solve equations that have our reciprocal functions, so secant, cosecant, and cotangent. And they're really not going to be any more difficult than the equations with sine and cosine and tangent. And from looking at the standards, we are not going to have to do inequalities with these. We're only going to do inequalities with sine and cosine, so that's good. All right, so we're going to start off exactly the same way, kind of in the middle. We have a thing to do, and then we'll finish the same way. So on example 5, we have f and g, and we want to find where they intersect. So just like always, we're going to set them equal to each other. Oops. And then we're going to isolate the trig expression, which in this case is cosecant. So we would subtract 3 and divide by 4. All right, and then once you get here, I'm going to change both of them to their reciprocals, which is something that you can do in mathematics. It's fine. And so what is the reciprocal of cosecant? Sine. So s and c go together, so it's going to be the sine of x is going to equal the reciprocal of 2, which is 1/2. So that's that extra thing you have to do. So once you get the secant or cosecant or cotangent isolated, then you're going to change them both to their reciprocals. And then we're just going to use the unit circle. And this one, we're given a range of numbers or an interval of angles that we want to find that have a sine of 1/2, and that's just the unit circle angles. And so that is going to be pi over 6 and 5 pi over 6. Right. All right, so let's look at example 6. So we have the same situation. So we just set these equal to each other. Get everything away from secant of x by subtracting 3 and multiplying by negative 1/2. Nope, multiplying by negative 2. Right, then we're going to change these to reciprocals. Right, and then this one, we have this interval of angles to use. That's just straight from your unit circle. So we want the angles from the unit circle whose cosine is negative 1/2 or whose x coordinate is negative 1/2. And it should be those two. All right, and then the last one is a calculator question. And I feel like I don't spend a ton of time with calculator questions in here. I do the same thing with my calculus class too. I focus more on the non-calculator, but you need to be able to type this stuff in to the calculator. And so we have, again, a function. This one is a cotangent function. It's got a couple of weird decimals. It's fine. And we want to find when it's equal to 2. So yeah, go ahead and grab a calculator if you don't have one. Okay, so we need in y1, we're going to put our p of x. And so that's going to be 3 minus 1.7. And then we need to be able to type in cotangent in the calculator. So there is a tangent to the negative 1. That is not cotangent. That is the inverse tangent. So if you use the inverse tangent, it's going to give you whatever angle has that tangent. It is not the cotangent. So we have to type it in like a reciprocal. And so what I would recommend you do is in the place of cotangent, you're going to do 1 over tangent. And then this 0.5x minus 1, we put that in right after the tangent. Now, if you wanted to, you could put this whole 1.7 on top, but it doesn't matter. Your calculator knows what you're doing. All right, and then what do you think y2 needs to be? 2. We want to find when this equals 2, so we'll make it 2. Now, I recommend that you do the alpha y equals fraction guy. Oh, my minus didn't. Guys. And whenever you do your window, pay attention to what this says. The x's we only want to be between 0 and 2 pi. So make your x min 0, your x max 2 pi. And then the Y min and max, I usually kind of do -4 to 4. You could do bigger, smaller, but you need to make sure that 2 is in your range. All right, let's look at this graph. Sometimes they will cross multiple times. Sometimes they'll only cross one. This one is only going to cross that one place. And so just like we always do, we're going to do second, trace, intersect. If it only crosses at one place, you don't necessarily have to put it close to the intersection, but it doesn't hurt anything if you do. And then hit enter 3 times. And when it says intersection down there, that's definitely going to be your answer.
How did you get that single line again? Because I've got 4 tangent lines already. I forgot how you did it.
Is this your window? 0 to 2 pi. Yeah? Okay. I can look at it if you want me to.
It was like the wide min and stuff. Was that all on default, or did you just now like edit those?
It could be. It doesn't. The Y technically doesn't matter as long as 2's in there.
Okay.
What matters is really the most is that. If something's wrong, I can look at it. All right. So make sure when you give your answer from the calculator, you're accurate to 3 decimal places. So some people just go to 4 decimal places and don't worry about rounding or truncating, or you can round or truncate at the third.